We have two examples, A and B. We show the 0 with the circle, and we cross, we use the pole. In this system, as you know, we have the s equal to the 0, 1 pole here, and s equal to minus 2, 1 pole here. And we have a 2 branch. Another one is the dominator is equal to 0. You have a 2 root. One root is here, one root here. That means you have a 2 root, you have a 2 pole, and a 2 branch. Another one is a rule number 2 is a symmetric. As you know, the symmetric in the x-axis, all of the root locus, they have a symmetric. Here do exactly the same here. Here we repeat it in the z-axis is a symmetric part. Rule number 3, on the real axis for the k bigger than 0, the root locus exists to the left of an odd number of the real axis. I will explain this one more. If you have a system something like this, you will define all of the pole and the 0 in the system. You have a s equal to minus 0.2, s equal to minus 1.5, s equal to minus 4, s equal to minus 1, and s equal to minus 5. If you see here, the s equal to minus 0.2 is a pole, s equal to this is 1, 0 here, 1 pole here, 1 pole here is minus 4, and s equal to minus 5, 1, 0 here. You put the number here 1, 2, 3, 4, and 5. Odd number will be on root locus. From minus infinity until 5 will be on root locus. All this point will be on root locus. Between minus 5 and minus 4, because different even number is not on root locus. Here will be reached to the 3, is odd number will be on root locus. That means between minus 4 and minus 3 is on root locus. 2 is not root locus. Between 2 and the 1 here will be odd number. We reach on this one become on root locus. I come back to this previous slide. Minus 5 to minus infinity on root locus. Minus 1.5 to minus 4. Minus 0.2 to minus 1 will be on root locus. It's easily I explain 1, 2, 3, 4, 5. Odd number will be on root locus. Even number will not be. Odd number will be on root locus. Even not, and the odd number will be on root locus. For the proof, it's very easy. You can use the second law of the root locus. You find the angle of the pole, and you will find the will be on root locus or not. Rule number 4. A starting and ending point. All the time the GS, the degree of the numerator should be less than the denominator. The first. Second, the number of the 0 to infinity or infinity 0 is equal to degree of the denominator minus the degree of the numerator. Here we give the examples. First, how many branches we have? We have the 3 pole, we have a 3 branch. The number, the n here is the number of the order number of the denominator is 3, and order number of the denominator is equal to 2. 3 minus 2, you have a 1, you have a 1 infinity 0, and you have a 2 infinity 0, minus 1 and minus 5. This is another example that they show us. We have the all the time pole go to the 0. One pole here they go to the 0. These two poles reach together and then break, and then they go to the 0. And another thing, you have the infinity 0. That means 2 0 go to infinity pole, and another one go to infinity. It's another example here. What is the transform associated to this root locus? We have a s equal to the 0, s equal minus 2, and if you find the root of here, this is we have a 2 pole here, 1 pole in the origin point, and 1 pole is equal to minus